In this lesson, we are going to learn some technical aspects of C#, specifically the structure of the script and its basic details. So, what is a script? In Godot's context, a script is a piece of code that allows us to control the behavior of a game node, among other things. Scripts can be extremely specific to a node or a scene, or more generic and be used in various elements of the game. It all depends on what we need to do. Before we start in Visual Studio, let's go to Settings, search Code Lens, and disable the option. This will clear all that text that appears on top of the script. For this demonstration, we will need a 2D-based scene. We change the name of the root node to script learn and save it as script learn. We also create a C# script inherit from node 2D, also named script learn. After placing it on the scene's root node, we edit the script. A script in C# has a specific structure. At the top of the script, we find the library declarations or using statements. These lines of code allow our script to access specific functionalities of Godot and the .NET framework. The using statements are used to import namespaces into our code. A namespace is a way of grouping related code. For example, all the code that deals with reading and writing files is in the system.io namespace. When we write using system.io, at the top of our script, we are telling the C# compiler that we want to use the code in the system.io namespace. This allows us to use classes and methods from that namespace directly in our script. This, on one hand, facilitates the reading and organization of the code, and on the other, the reuse of more generic functionalities. After the using statements, we have the class definition. The name of the class must match the name of our script file for the code to run in Godot inside a node. The class is where things happen. This one specifically is a public class, which means it is available for other classes to access, with a unique name, and inherits from the base class Node2D, which means that all the methods within Node2D are now accessible and can be used in this script. For example, when we directly change the position without having to declare any position variable in the script from the last lesson. In Godot, it is still necessary to add the partial property. This allows the class to be compiled as a part of the final class, which means, for example, that a team of programmers can work on different parts of the same class in different files, and yet the compiler understands everything as a whole. Another possibility is when something generates code automatically, like a plugin, for example, and that code needs to be integrated into the class. However, in this series, we will not address this topic. We will often see methods being called functions and vice versa. Technically, they are the same thing, but in C#, the term method is conventionally used. A method is a routine or function that performs a specific task. The creation or declaration of a method in C# includes the access definition, the modifiers, the return type, the name, and the parameters. When creating a new script, two methods are included by default, the ready and the process, which come from the Godot's engine. The ready method is executed once before the first frame when the node containing the script enters the scene. It can be used, for example, to set the initial values of a script. The process method will be executed once every frame. Here is where the game happens, and its cadency depends on the capabilities of the computer where it runs. If the computer is very powerful, this method will occur more times per second, and it will make the game run faster. To avoid different experience with different computers, the delta parameter is introduced in the method containing the frame time and allowing to calculate the speed of events. Godot has many other methods available for the most varied functions. However, we should consider that we can also create our own methods. This helps to organize the code and avoid repetitions when we need to perform the same tasks in various places. We will create a new method to understand this concept and analyze its structure. Within the class, but outside of the other methods, rewrite the following code. Private float my calculator open parenthesis float a comma float b close parenthesis enter open brackets enter return a plus b semicolon. Structurally, a method is declared and contains a body. In the declaration, we define the access level, private or public, its return type, in this case a float, a number with decimal places, its unique name in its mother class, and some arguments, in this case two floating numbers. The access level being private means that only within this class we will be able to access the method. If we want to access it from another script, we have to make it public. The return type defines what the method will return when it's called to execute. This means that it will respond with a float number when executed. The arguments allow data to be introduced into the methods. We do that when the method needs some kind of value to work. Inside the ready method, we write float result equal my calculator open parenthesis 4, 7 close parenthesis semicolon. The next line gd.print open parenthesis result close parenthesis semicolon. We save, go back to Godot and click on Run Current Scene or F6 to run the selected scene. As soon as the scene starts, we see the number 11 in the console. Why? gdprint writes to the console whatever is inside the parentheses. In this case, the value result, which is a float number. In the previous line, we see that the value result is equal to my calculator for 7, our method. Since our method has a return type, it is expected that when called to execute, it will deliver back something of that type. In this case, when the method executes, the return command will return whatever is in front of it, which is a plus b. But what are a and b? They are variables, the arguments that the method expects to work. In this case, 4 and 7. When we write result equals my calculator for 7, we are ordering the execution of my calculator and introducing the values 4 and 7 into the two variables. When executed, it returns the sum of a and b, or 4 and 7 in this case, which is 11. So, result is equal to 11. Of course, for a simple sum, it doesn't make sense to have an extra method. But as we can imagine, the method can do much more complex things with the introduced data, and whenever that complex result is expected, we just have to send the data to the method, avoiding programming all the code whenever necessary. Not all methods have a return type. It may just be expected that the method performs some function without necessarily returning anything on request. In these cases, we use the return void, meaning that the return value is, let's say, empty. Examples of this are the ready and the process methods, but any method created by the user can also return void. Regarding the arguments, they are also dependent on the method's functionalities, and it is also common to see methods with empty parentheses. This means that the method does not expect values to work and can simply be called to execute the code. However, we always have to match the expectations of the methods. If they have arguments, we have to give them some value. If they have a return, we must send that return somewhere else. In summary, return and arguments in methods are one of the ways that the game elements have to communicate with each other and pass information. For example, to make the characters interact with each other, with the world, with the interface, with the save system, etc. In this example, we also used variables, so let's explore that right away. To store and work with information in our scripts, we use variables. Variables are space in memory that can be accessed and modified in real time, allowing the code to evolve over time. A variable has a type, a name, and a value. For example, int player life equals 3. This is a variable of type int called player life with a value of 3. Let's focus on the most common types of variables. Int refers to integer numbers. In our script, we can use an int to save the number of the player lives, as in the previous example. Float refers to numbers with decimal places. For example, float speed equals 3.2f can represent the speed of our player. Double is similar to float but allows greater accuracy. Double force equals 1.2345678, etc. However, for the most game processes, float is sufficient and more efficient from a processing point of view. What distinguishes the double from the float is the letter F at the end of the float. String refers to text. For example, string player name equals player1 inside quotation marks. Be careful because if the string variable contains numbers, like for example string player name equals 1234 inside quotation, the system will not see the number 1234 but rather the name 1234. The numerical digits are treated as if they are letters and have no value and cannot be used in arithmetic operations. Bool refers to Boolean or true or false values. For example, bool is player alive equals true could indicate the player is alive. The other possible state of a Boolean variable is false. Each variable has an access modifier, which can be public or private. A public variable is accessible to other scripts or classes, while a private one can only be used within the scope where it was declared. If the variable is declared without an access modifier, by default in C# it will be private. The variables declared at the beginning of the class are available to all methods, but those declared within a method alone are only accessible within that method. In Godot, public variables can also appear in the inspector, so that we can change them directly from the Godot's interface. To do this, we have to add the export inside square brackets attribute before the variable declaration. For the variable to effectively appear in the inspector, we must click on Build or run the scene at least one time for the script to be compiled. We can also create variable structures. A struct can house more than one value of more than one type, and it's useful when we have several objects that need the same data structure but contain different values. For example, in a racing game, all cars have a name, maximum speed, and range. In this case, it's easier to organize the data when we create a struct. System serializable inside square brackets, public struct race car, open curly brackets, public string name, public float speed, and public float fuel. This is the body of the struct, and whenever we need to add a car to our code, we just have to declare a variable of type race car. To access the variables, we use the following structure. Ferrari.name equals F40 inside quotation marks, or Ferrari.speed equals 270. We use the dot to navigate within the variable structure and reach the intended destination, not only to write but also to read the variable. The last type of variable that we should consider and that will be used many times, it's the type reference. We can use any class as the type of the variable and easily access other nodes and scenes in the game. Export player p. P is our variable of type player, which is our other script. Player has a speed variable. It is not yet public and it needs to be so we can read it outside of the player script. In the player script, add public to the speed variable. In the level 1 scene, we add the script learn scene. Selecting this scene, we can see the variable p empty. Clicking on a sign, we should be able to choose which element has the player class. In our case, it is the player scene. Now, p is a reference to player that we can access it by calling p. In the script learn script, write inside the ready method gd.print open parenthesis p.speed. This will write the speed value in p to the console, which is the value in the player script. This way, we are accessing data in one game element from another. We can read or write to modify the values of one to another, but everything depends on what we are trying to do. The first part of the exercise of this lesson is to copy the entire project as demonstrated in the video. The second part of the exercise is to create a C# script inheriting from Node to D called student. Add the necessary variables to hold your personal information: name, age, height, and whether you like pineapple on pizza. Use the variable types you consider appropriate to each field. Make the script write this data on the console, preferably in a sentence rather than loose data, whenever the player presses the space key.